Today we will go over how to do a thin layer chromatography, which is a method used to separate substances into their specific separate components. But first you need to gather all necessary materials. For this TLC we will be using a TLC chamber with the lid, filter paper, 2 TLC plates coated in silica gel, ethanol to be used as our solvent for the mobile phase, and then 2 pens, which will essentially act as our sample that we will be testing and separating into the specific components. The graduated cylinder is used to properly measure and make sure that we aren't using too much or too little ethanol as our solvent. Next, we will take our 2 TLC plates, one for the blue marker and one for the green marker, and draw a line across the bottom side that will be used as a reference point to measure the RF values of the TLC. I will go into a little bit more detail about how this helps determine the RF values later in the video, but first let's draw a line and sample the TLC plates at the bottom half. After we spotted the sample on our TLC plates, we want to now put the right amount of solvent, which was ethanol, in our TLC chamber. We don't want to put too much solvent because then that would ruin the mobile phase by completely covering the sample. Put the right amount of solvent just to cover the bottom half underneath the line that you created. Now at this point you also want to add filter paper. Filter paper is useful because it essentially provides more surface area for evaporation. So the more evaporation there is more solvent vapor in the chamber's air, which is desirable. Now before you put the actual TLC plate that you sampled in the chamber, you want to make sure that the solvent is in there and then the filter is in there. Make sure that you put the solvent with the filter paper before you put in anything else. Otherwise, you could potentially ruin the mobile phase, thus making the experiment useless. After carefully placing your sample TLC in the TLC chamber with the solvent and the filter paper, allow the solvent to rise across the TLC plate. You will see the darkened white part of the TLC plate increasing and some of your sample moving with the solvent. This is because of the mobile phase. Now it's important to understand the science and the chemistry behind the mobile and stationary phase. The reason compounds are able to separate is because they have different polarities. The stationary phase, which is defined by the silica gel, is what attracts polar molecules. The more polar a molecule is, the more likely it is to be attracted to the stationary phase, which means it would be closer to the line that you draw in the beginning and closer to the bottom of the TLC plate. Now less polar compounds will be more attracted to this mobile phase, meaning that they will move up with the solvent front, making them higher on the TLC plate. Now after you've let your solvent rise at a considerable amount, probably closer to the top, you should take it out and immediately mark where the solvent front ends. Now it's important to note at this point that although we can see clear separation of compounds using markers, generally in the chem lab when you're using different samples of chemicals, you won't be able to see them right away. So in order to properly see them, you should probably put them under some UV or fluorescent light or find other visualization technique that will allow you to see the actual separation. If we were to analyze this TLC plate qualitatively, we could see that the green marker looks like to be the more polar one as it is closer to the bottom half, and the blue one seems to be more nonpolar as it is closer to the top half. We can also see a little bit of the separation of the green marker through the yellow color that's formed and the blue color that's formed. This is very similar to what you would see after you do a proper visualization technique on different chemical samples and then take it to the lab. You can take your TLC plate a little bit further and do some quantitative analysis using RF values. In order to properly do an RF quantitative analysis, you want to take the distance the compound has traveled from the origin and divide it from the total distance the solvent front has traveled. This way you can have a considerable amount of information to tell you about the general ratios and use them to do some comparative quantitative analysis between different compounds and components.